Hello class, I am Happy Narang, your subject teacher of Fundamentals of Soil Science. Today I am going to cover the topic that is physical properties of soil. So let's start. Physical properties are soil texture, soil structure, surface area, soil density, soil porosity, soil color, soil consistency. So first we'll talk about soil texture. Soil texture refers to the relative proportion of particles. It is the relative percentage by weight of three soil separates, that is sand, silt and clay. Simply refers to size of soil particles. The soil separates are defined in terms of diameter in millimeter of the particles. Naming of soil separates are USDA, BSI, ISSS, European system. Here is types of soils and their diameters. So let's start. Clay diameter is less than 0.002, silt 0.002 to 0.02, fine sand 0.02 to 0.2, coarse sand 0.2 to 2. Particles less than 2 mm is called fine earth, normally considered in chemical and mechanical analysis. The component fine earth, that is sand, silt and clay. The percentage of clay and the percentage of silt and sand we can observe by this figure. Sand consists of quartz but may also contain fragments of feldspar, mica, etc. and can be represented as spherical. Intermediate between sand and clay, small size and more surface area. Clay particle size less than 0.002 mm, plate-like or needle-like shape, belongs to aluminosilicate group of minerals as shown in the figure. There are some methods of textural determination that are Elutriation method, that is water and air, pipette method, decantation method, test tube shaking method, feel by fingers, ball formation, stickness or ribbon formation. Importance of soil texture is texture has good effect on management and productivity of soil. Sandy soils are poor storehouse of plant nutrients. It contains low organic matter. Clay particles play important roles in soil fertility. Loam and silt loam are highly desirable for cultivation. So now we will discuss about soil structure. The arrangement and organization of primary and secondary particles in a soil known as soil structure. Structure is described under three categories: type, shape or form, and arrangement pattern of pads, class, size of pads, grade, degree of distinctness of pads. So first we'll talk about the plate-like. The aggregates are arranged in horizontal plates or leaflets when they are thick, platy, thin, that is laminar, prism-like. The vertical axis is more developed than horizontal, giving a pillar shape. Length 1 to 10 cm, commonly occurred in sub-horizons of arid and semi-arid regions. When the tops are rounded, that is columnar. When flat, plain, level and clear-cut, that is prismatic. Block-like, all the dimensions are about the same size. The aggregates are reduced to blocks when the faces are flat and distinct and the edges are sharp angular, that is angular blocky. When the faces and the edges are mainly rounded, sub-angular blocky. These types confined to subsoil. Now we'll discuss about the spheroidal. All rounded aggregates are placed in the category. The aggregates of this group are usually termed as granular, which are relatively less porous. When the granules are very porous, that is crumb, This is specific to surface soil, particularly high in organic matter or grassland soils. Different type of structures shown in the figure. There are some classes of structure depending upon the size of the individual beds. Very fine or very thin, fine or thin, medium, coarse or thick, very coarse or very thick. The term thick and thin are used for platy types, which the terms fine and coarse are used for other structural types. There are some grades of structure. Grades indicate the degree of distinctness of the individual parts. Structureless, there is no noticeable aggregation. Weak structure, poorly developed, which are not durable. Moderate structure, moderately well developed parts which are fairly durable and distinct. Strong structure, very well formed parts which are quite durable and distinct. There are some factors affecting soil structure, and that are climate, organic matter, tillage, plant roots and residues, and exchangeable cations. Here we will discuss about the soil density. Density of a soil is expressed as weight per unit volume. Soil density expressed in two concepts: particle density, absolute specific gravity, bulk density or apparent specific gravity. The particle density of normal soils are 2.65 gram cubic centimeter. The bulk density of the normal soils ranges between 1.00 to 1.6 gram per cubic centimeter. This table shows the bulk and particle density. There are the textural classes and particle density of different soil having different particle density. Coarse sand 2.655, fine sand 2.659, silt 2.798, and clay is 2.837. There are some types of soils and having different bulk density and different pore spaces. Sandy soils, bulk density is 1.6 and pore space is 40%. Loam, bulk density is 1.4 and pore space is 47. Silt loam, bulk density is 1.3 and pore space is 50. Clay, bulk density is 1.1 and pore space is 58. This figure shows the bulk density, that is mixture of air, water, minerals and organic matter. And particle density is all about the pore space and solids as shown in the figure. Here we'll discuss about the soil porosity. The pore space of a soil is the space occupied by air and water. In sandy soil, the pore space is low. In clay soil, pore space is high. Presence of organic matter increases the pore space. Here is the calculation of pore space, that is percentage solid is equal to bulk density by particle density into 100. Percentage pore space is equal to 100 minus solids. Pore space is equal to 100 minus in bracket bulk density by particle density bracket close into 100. Porosity is equal to 1 minus in bracket, we can use bulk density by particle density. By this figure we can observe this. There are some factors influencing pore space, that are soil texture. Sandy surface soil, that is 35 to 50%. Medium to fine textured soils, that is 50 to 60%. Compact subsoil, that is 25 to 30%. Vegetation, biological activity, size of pores, that is macropores, or we can say non-capillary pores, that is greater than 0.05 millimeter. Micropores, that we can use in another words capillary pores, and that is less than 0.05 millimeter. Here we'll discuss about the soil color. Soil color is due to the reflection of EMR by different soil constituents like minerals, organic matter, water, salts, etc. The occurrence of two or more patches of color is called mottling. It is due to the presence of iron, manganese, and copper in soil in patches. Soil color is inherited from the parent material and that is referred to as lithochromic. For an example, red soils developed from red and stone. Measurement of soil color is measured using Munsell color chart and expressed in terms of hue, value, and chroma. Hue denotes the dominant spectral color. Value denotes the intensity of color. Chroma indicates the purity of color. 10yr 5 by 4 means the hue value is 10yr. 5 is the value and 4 is the chroma. By this figure we can observe the different soil color chart. There are some factors influencing soil colors that are parent material, soil moisture, organic matter, mixture of organic matter and iron oxides, alternate wetting and drying condition. Now we'll discuss about the soil consistency. The resistance of a soil at various moisture contents to mechanical stresses or manipulations. It combines with both adhesive and cohesive forces which determine the soil can be reshaped or ruptures. The soil consistency is described at three moisture levels: wet, moist, and dry soil. Wet soil consistency is denoted by stiffness and plasticity. By this figure, we can observe the soil consistency: loose, friable. Soil with single grained structure always have loose consistency. Atterberg's constants. He studies plasticity from the point of view of moisture range over which plasticity range is maintained. Shrinkage limit or lower plastic limit, liquid limit or upper plastic limit, plasticity number, that is the difference between the consistency of upper and lower plastic limits. There are some factors affecting Atterberg's constants and that are clay content, nature of clay minerals, nature of exchangeable cations, organic matter content, cohesion, sticky point, swelling and shrinkage. This figure shows of the foundation of the nation is our soil. Thank you. Stay home. Stay safe.